This online lecture is going to go over the 3 practice problems that I handed out. I think it was on green or blue paper before giving out the quiz on Thursday. The reason I did these problems is because you do not have a quiz scheduled for these last 2 sections in chapter 12 before we take the test. So as I wrote on that piece of paper, I would encourage you to write down the problems. First study section 12.2 and 12.3 as if you were to have a quiz. Then find a quiet space, put your notes away, sit down and see if you can do those problems on your own. If you get stuck on them, then make a note of it as something you need to go back in and study. Maybe before you watch this online lecture, you want to look back over your notes and see if your notes can help you guide you through those problems. And then, of course, you can continue with this online lecture to see what you did right and wrong on those particular problems. So let's go ahead and get started. What we have here is the integral of 8x to the 5th times the quantity 4x to the 6th plus 7, all raised to the negative 3 power. So we did these problems in section 12.2. We don't have a rule like a chain rule or a product rule or something of that nature for integration. So what we use instead is U substitution. So this thing inside of the parentheses, well, that's a little bit too much. So let's do this thing right there. Inside of the parentheses, that's going to be our U. So over here on the side, we say, all right, I'm going to let U be 4x to the 6th plus 7. Then I'm going to take the derivative of U with respect to x, like we always have done, and that's 24x to the 5th. Now the reason that we do this is so that we can actually solve for dx and then plug it back in. So I'm going to multiply both sides by dx. And the last step is to divide by 24x to the 5th. So you can see that du over 24x to the 5th is equal to dx. All right, now I'm going to go back to my original problem and I'm going to substitute things in. So let's see, we have the integral. We have this 8x to the 5th hanging out there. Inside of that parentheses, I said that was going to be u, so that's going to be u to the negative 3rd power. And then dx I'm replacing with du over 24x to the 5th. Now notice I haven't done any integration here. I've just simply done some substitution. So on these problems, step 1 is to identify u. Step 2 is to take the derivative of u with respect to x. Step 3 is to solve for dx. Step 4, go back to your integral and substitute things in. And we hope, as we see here, we can get rid of the x's. That 8 over 24, 8 is in the numerator, 24 would be in the denominator. That can come out in front of my integral, and that can be reduced. 8 goes into 24 3 times. So I have left over the integral, 1/3 times the integral, u to the negative 3 du. Okay, now I'm ready to integrate. So that 1/3 will stay there. The integral of u to the negative 3 is u to the negative 2 over negative 2. And when we integrate, we have to make sure that we keep in mind there could be a constant as well. So we write plus c. Now remember, the way the negative 2 came from is you take the exponent and you add 1. Negative 3 plus 1 is negative 2, and that becomes your new denominator. So down here on the denominator, we have 3 times negative 2. So that's negative 6. So you can just write that as negative 1/6. Then you want to replace your u with 4x to the 6th plus 7. That's raised to the negative 2 power. Plus, this is technically a different constant. This would be a constant affiliated with the x's instead of with the u's, but it's a constant nonetheless. Now you can rewrite this if you want. This would be equivalent to 1 on the top with the negative 6 times that quantity raised to the positive 2 power if you want to bring it down to the denominator. But this is perfectly acceptable to leave just as is. So again, you can rewrite this. There's a lot of different ways you could rewrite it, but that's what we're looking for our final answer. or one of the versions of a final answer that would be acceptable. Just make sure you don't forget to go ahead and substitute the x's back in once you make that u substitution. Okay, let's look at number 2. Let me stop and say that this actually came from section 12.2. We did a ton of examples in class. So if you need more practice, you could rewrite some of those examples, look in the ebook, go over some practice problems from 12.2. These next two problems come from section 12.3. The things that we want to remember from 12.3 is that if we're integrating 1 over u, or u to the negative 1, let me write these down. So u to the negative 1 du is the ln of u plus c. And when we integrate e to the u du, that's equivalent to e to the u plus c. So those are our new integrations that we want to be using. Okay, so let's first rewrite this integral. You don't have to, but I think it's a little bit easier to do these problems if you realize that that denominator, 5x squared minus 2, is the same thing as writing it to the negative 1 power. So I can leave that denominator as a group, bring it up to the negative 1, and then it's really a little bit clearer to see what your u needs to be. So I'm going to use red so it doesn't mix up with my my formulas over here. So if I have u equals 5x squared minus 2, I take the derivative of u with respect to x. That would be 10x. So it would normally be over dx. Here I'm going to multiply both sides by dx and get rid of the dx. And then now to solve for dx, I'm going to divide both sides by 10x. So du over 10x is my dx. And I'm going to go ahead and make my substitutions. That 9x hangs out there. Then I have, well, I don't need that parentheses. Then I have u to the negative 1. And then I have du over 10x. So what I did is I replaced my parentheses with my u. I replaced dx with du over 10x. And we are happy because our x's cancel. I have a 9/10 that comes out in the front. And then I'm integrating u to the negative 1 du. And we said that u to the negative 1 du is the same as the natural log of u plus c. So I'm ready to integrate. And when I integrate, then that integral symbol and the closure of my integral, those two things go away. When I integrate, giving me the natural log of u in the absolute value, we talked about that in class, plus a constant. And my last step is to replace u with 5x squared minus 2 so that I'm answering an x's type of question with x's. We do need to keep that absolute value in there. Depending on what we were to plug in for x squared, we could get a negative value of that whole thing once we subtracted 2. If you're not sure how that would work, because I know x squared is positive, right? And you multiply it by 5, it'd be positive. But if it's a small number, like 1/4, if you plug that in, you're going to end up having a negative value. So you do need to leave the absolute value there. Okay, so the one thing that you want to get in the habit of, and I would say the thing that just to be the most careful of, is just identifying this original problem as 1 being a u substitution and 2 being a u to the negative 1. I think once you identify that, it's pretty smooth sailing as long as you understood section 12.2. But rewriting that as a parentheses to the negative 1 power, that first step is super critical. Let's do one more. Now we have the piece where we have an e to the u, and since it was on the previous screen, let me just remind you that when you integrate e to the u, you get e to the u plus c, just because it's the opposite of derivatives, and when we took the derivative of e to the u, it was e to the u times u prime. So we really are dealing with the same thing here. Okay, so hopefully you're looking at this and thinking, well, I know what my u needs to be, right? It's that exponent. So u equals 3x to the 4th. Take the derivative of u with respect to x, and you get 12x to the 3rd. Solve for dx. And at this point, when we see that dx, well, here, I'll write it on the other side. So du over 12x to the third power is dx. When I see that I've got an x to the third, that makes me happy because I have an x to the third in my integral that I need to get away. So let's go ahead and rewrite our integral. That x to the third hangs out there for a minute. Then it becomes e to the u, and I replace dx with du over 12x cubed. Yay, the x. Sorry, I hit a button on the iPad. Okay, so the x cubes cancel. So that leaves me with a 1/12 in the front of my integral. Some of you asked if it's okay to have it on the inside. That's totally fine. Either way is acceptable. But I'm trying to stress the fact that we're integrating e to the u du, and we know that's e to the u plus c. So the 1/12 stays there. I'm going to go ahead and integrate. I get e to the u plus c. Notice that it's very clear when I'm integrating. Because I'm integrating, I'm getting rid of the du, I'm getting rid of the integral symbol. That's the same step when my constant comes in, because there could be a constant anytime we integrate. All right, last step. Go ahead and plug in. Let's see, our u was 3x to the fourth plus c. Now, one thing I'm realizing that I haven't said much in class, but I want to bring up here, is you might be able to notice some patterns. And there are some students that will go from step 1 all the way down to this 1/12 e to the u plus c, with the u being 3x to the fourth. I need you to show me how you get this 1/12. And if it's because you have magically seen a pattern that works for these types of problems, I understand that. But your work is very important to me. So make sure as you're doing these problems that you are taking the time to show, yes, Roxy, they hear you. Yes, got it. Sorry, that's my son's dog. Okay, so make sure you take your time of showing your work, each of these, when you're working through the problems on your notes, when you're working through the problems on your homework, and then next thing you know, it becomes autopilot. All right, I better stop there because the dogs are interrupting me. All right, hope this helps. Enjoy your weekend. Happy studying. I will be grading quizzes and Math 108 tests. You guys are doing a great job in general on the class. Keep up the good work. I know this isn't easy stuff.